Hello, I am Abhilash Chand and welcome to Complete LaTeX tutorial series. In this video, we shall learn about tables part 2, few frequently used packages and their functions, and how to insert various graphics or figures in a document, in addition to how to comment out some phrases in editor window. You may practice writing this document with me. So, without further ado, let us start today's class. First, let me save this untitled document as class 6. Now, in preamble, let me define my document class. And as I have mentioned in my previous classes, I will always use AMS Math, AMS Sim, AMS Font packages in all of my documents. And also, let us use \parindex 0px so that by default my new lines will be starting without an indent. Now I am going to create a title page as I have shown in my previous classes. Okay, as you can see, our title page is created. Now let me create a section named as few routinely used packages and their functions. If you can recall, in our introductory class, we have mentioned in many cases creating a LaTeX document require packages that provide additional options or functionality. Packages allow us to use extra commands without having to include tons and tons of code in the preamble of a document. Instead, we just add the line \use package in curly bracket package name, and we have access to all the commands, symbols, environments, etc. that are in the package. Now let me write briefly about packages. There are many packages like enumerate, AMS Math, AMS Sim, AMS Fonts, etc. we have used frequently in our previous classes. Now here we will learn how to insert a figure or image into our document with the help of a package. It is one of the most important and most frequently used package in a documents, because many times you may need to insert a graph, figure or logo of a university, projects, etc. in your document. You can add any image and even alter its size according to your need, and even rotate to any angle with the help of a package. So we'll learn how to do all this with the help of a package. First, let me create a subsection for it named as graphics. Okay, our subsection is created. Sometimes we need to input graphics or say images, graphs, logos in JPEGs or PNGs, etc. for various purposes in our document. Here, one important thing to keep in mind that first we need to save these image files, JPEGs or PNGs, etc. in the same folder where the text file is saved. So here I have made a graph of a certain function which is of heart shaped with the help of Wolfram Mathematica, and I have saved the corresponding JPEG file in pictures folder so that it will be easier for me to find. Let me go to that directory. So let me go to the pictures and let me go to LaTeX sample images. So as you can see, I have named my graph as heart and saved this in pictures and LaTeX sample images. So let me open this graph. Now I want to include this heart-shaped graph in my LaTeX document, and as I have mentioned, first I have to save this JPEG file in the same folder where my text file is saved. First, let me copy this JPEG file. Now let me go to the directory where my text file is saved. As I have shown at the start of this video, I saved this classes text file in documents LaTeX classes directory. So let me go to that folder and paste this heart JPEG there. So let me open LaTeX classes and paste my heart shaped JPEG here. So this is the most important step to include images, graphs in a LaTeX document. These images are needed to be saved in the same folder where the text file is saved for the compiler to find these images, otherwise we'll get a compiling error. Now our first part is done and we can use this graph in class 6 document as many as times we want. Let me go back to my TeXmaker window. Okay, before proceeding further, another useful thing I should mention here about how to comment out a phrase in editor window. Sometimes we need to write something useful in coding section or in editor window for our future references, which we don't want to show up in our output window. We can easily comment out that phrase in editor window so that LaTeX will ignore that phrase when we compile or hit run. To comment out some phrases or sentences, we need to add a percentage symbol before that sentence. Let me demonstrate this. I am going to write the sentence how to comment out a phrase or a sentence in editor window. Now let me run this. So as you can see, after compiling our document, here in output window, the sentence how to comment out a phrase or a sentence in editor window is showing. Let's say I don't want this sentence to show off in my output window, but I want this sentence in my editor window. So for this, I'll just add a percentage symbol before this. Now let me again compile my document here. Okay, as you can see in output window, we cannot see the sentence how to comment out a phrase or a sentence in editor window. But here in my editor window, the sentence how to comment out a phrase or a sentence in editor window is still present. Another thing you can notice is that here in my editor window, the commented out sentence turns gray just as in LaTeX. Math mode text turns green. Next, let's say if I want this sentence to show up again in my output document, then I'll just have to remove this percentage symbol here and compile again. But for now, let's leave this as it is. Next, let's come back to graphics. To include graphics or images etc. in a LaTeX, we need an additional GraphicX package. Let me go to the preamble to write the code for GraphicX package. So here I have written \use package in curly bracket GraphicX, and since we have just learned about commenting out some phrases in LaTeX, let me write briefly about the functionality of GraphicX package in coding section. So we use GraphicX package to add some images in a document. So commenting out some phrases is very useful because after a while when I again come back to this text file, I would exactly know the functionality of GraphicX package. Now let me go back to my document environment. So the most basic way to include graphics is using the command \include graphics, then in a square bracket scale equal to our required size in a decimal number, followed by another curly bracket in which we need to write the name of that particular image file with or without an extension. Let me demonstrate this by writing the exact code. So as you can see, here I have written \include graphics, then in first square bracket I have written scale equal to 0.4, then in second curly bracket I have written the name of my image file which is heart, and I have no need to mention the extension .jpeg or .png here as it is optional. Now let me compile this. So now in our output we can see the heart-shaped graph. Similarly, we can add any image file to our document. Now let's say I want to reduce the size of my graph, then I can type 0.2 instead of 0.4 as a scale. So let me change scale to 0.2 and run this. So as you can see, the size of the graph is successfully reduced. But for now, let me keep the size as 0.4 and run this. Okay, now there is another way of changing the size of our image in which we are in complete control of width, height and angle of our image. So let me write the exact code after adding a bit of vertical space using \baseline script command as I have shown in my class 3 video. Okay, so here as you can see, in this way of adding an image in first square bracket, instead of using scale, we have exactly defined angle, width and height of our image. Now let me run this. So here in this way, we can be in complete control of our image. Similarly, using this code, we can rotate any image by a certain angle. So if I want to rotate this image by let's say 20 degrees, then I have to type angle equal to 20 here. So let me demonstrate this by writing the code. So here I have written angle equal to 20, rest are same as previous one. Now let me run and see what happens. So here as you can see, our image is rotated by an angle 20 degrees here. Next, if we want additional control of our image, we need to put this image in figure environment, that is between begin figure and end figure. Let me write the code here. Okay, now let me run. Okay, as you can see, it is taking my image randomly to middle part of my next page. So as I have mentioned in my class tables part 1 video, here we also need an additional float package to resolve this issue. So let me write float package in preamble. Okay, now I have written float package in preamble. Next, as we have done in class 4 video, here also we need to write h in square bracket after begin figure to resolve the issue. H stands for here. Now let me write h in a square bracket after the begin figure. Now if I run this, it should resolve the issue. Okay, as you can see that my image is exactly where I have written my code. Similarly, instead of h, we can write lowercase t or lowercase b in square bracket to move our image to top or bottom of the page respectively. Next, we will add a caption to our image. First, let me create a subsection for this. Okay, our subsection is created. Now let me write the above figure in center of my page using \centering command so that when I add a caption to either top or bottom of my page, it will look bit better. Okay, so here I have written the above code using centering command. Now let me run this. Okay, you can see that our image is created in the center of the page. Now I am going to add a caption to this image. First, I'll add a caption at the top of this figure. So to add a caption at the top of image, we need to write \caption command followed by a curly bracket in which we'll write our caption. Since here we want to add a caption at the top of image, we will use the caption command just after begin figure. Let me write my caption code here after begin figure. Now if I run this, you can see that my caption is appearing at the top of my image. Similarly, if I want to add the caption at the bottom of my image, I need to use caption command just before end figure. Let me write the code to demonstrate this. So if I run this, you can see that my caption is appearing at the bottom of my image, and here I have used my caption command just before end figure to achieve this. Moving on, before I name few routinely used packages and their functions briefly, I am going to create a unnumbered subsection named as tables part 2. Okay, our unnumbered subsection named as tables part 2 is created now. Okay, if you can remember, in our class 4 video, we have discussed about tables part 1. There, in that video, we created a simple table manually consisting of 2 rows and 6 centered justified columns. In that class, we also learned about using rstress command in tables environment to alter cell sizes of a table, in addition to using float package, and also added caption at the bottom of the table. Now, today, we shall create some more fancy tables and also learn to create tables easily without typing all the codes manually with the help of wizard tool. First, let me create a table consisting of 2 rows and 2 columns with the help of wizard tool. So I will click on this wizard here, then I will click on this quick tabular. So as you can see, a new window pops out. So clearly here easily without typing all the codes manually, we can create a table. So let's say if I want to create a 2 rows 3 columns table, then I'll just click on here, and as you can see in my preview window, there is a 2 rows 3 columns table. Similarly, here in alignment, by default it is set as center, that is all the columns are centered justified. So if I click on this center, you can see that I can change my column entries to left justified or right justified, or fixed width left, fixed width center, or fixed width right as per my need. But for now, let's just leave it as center justified. Also, since my objective is to create 2x2 table, so let me change back my number of columns to 2. Okay, as you can see, this is 2x2 table. Also, you can see that here in wizard tool, we can directly alter left border, top border, right border, also can merge columns, etc. You can explore these options by yourself. Now let me add entries to cells of the table. So in first row, first column, let me write f prime x in math mode. Okay, I have written f prime x in math mode in first row, first column of this table. Now in second column, I will write 0. Next in second row and first column, that is here, I will write fx in math mode. And finally in my last cell I'll write the function is constant. Okay, now if I click on this OK, my 2x2 table is created without typing the codes manually. Now let me compile and my 2x2 center justified columns table is created. Now let me write the above table again after adding a vertical space of 12 point and giving it a caption say the nature of functions at the top of table. I want to place it in a table environment and move this table to center of the page. So let me write the appropriate code here. Okay, so I have written the required code. I am not going to waste your valuable time explaining the code here. I have written just now as I have already explained everything written here. You may pause the video and note the code and practice on your own. Now let me compile and see what happens. So as you can see, I am getting my desired table. Next, let me show briefly how to write tables with left justified columns. It's fairly simple process. First, again let me copy and paste the above table. Okay, now since my objective is to construct left justified columns, I'll just change the C's to L's here. That is, I have to change my C's to L here and here. Now if I run, you can see that all these entries are left justified, where in above table all these entries were center justified. Similarly, you can experiment with left or right or center justified columns according to your needs. Also, you can see that in this way of table creation, we didn't have to type manually table 1 or table 2 etc. That is, LaTeX does caption numberings automatically. Next, we'll learn about how to deal with a really long sentence which breaks into next line in a table say. So let me copy and paste above table with a second row and second column entry having a random long sentence to illustrate what happens. So let me write the code. Okay, now let me run. As you can see in output, this long sentence does not break into next line automatically and this long sentence does not fit into the cell. Now let me copy and paste the same table again and run it again. Okay, as you can see, this long sentence does not fit into the cell here. So if you can recall, in class 1, we faced a similar type of problem while writing a long underlined sentence. Anyway, to fix the issue here, what we can do is, since our second column contains the long sentence, so instead of this second L, we can replace it by P followed by a curly bracket containing its size, let's say 210 point here, where P stands for paragraph. That is, here we want our second column to contain a paragraph, and in curly bracket I have written 210 point as size of my cell. Here instead of point you can also use centimeter or inches or any other measurements to denote the size of the cell. Now let me run and see what happens. Okay, as you can see, our issue is resolved here in this output, and the cell of the table now contains whole long sentence. Next, we'll learn about merging multiple rows and columns in a table. So in LaTeX, columns can be merged without any additional package, whereas for rows we need multi-row package. First, let me write the code of multiple column merging. So here the code is \multi-column. In first curly bracket we write number of columns, and in second curly bracket we write alignment, that is whether it is left justified, center justified or right justified, and in final curly bracket we write the most column contains. Now let me write the code of an example where merging of columns is done. Okay, first let me run this. So as you can see, here in output all the three columns are merged in second row. So if you look at my coding section, In first curly bracket, I have written 3 because I want to merge all the 3 columns, and in second curly bracket, I have written C as I want my third curly bracket content, which is multi-column, to be center justified. You may pause the video and note down the code and explore other possibilities. Next, we'll do row merging. As I have mentioned, for row merging, I'll need additional multi-row package. So let me write the multi-row package in preamble. Okay, I have written multi-row package in preamble. So let me go back to my document environment and write the code for row merging. Okay, this is the code for row merging. Here in first square bracket, which is optional, we write vertical alignment, which is either lowercase t or c or b for top, centered or bottom justified. If we leave out this bracket, then by default it will be centered justified. In second curly bracket, we define number of rows, and in third curly bracket we define the width of the merged row. Here generally we use star as width in multi-row command, as it will be treated as natural text width, but here we can also use other measurements like centimeter, point, inches, etc. And finally in last curly bracket we write the contents of the merged row. Now let me write the code of an example where merging of rows is done. Okay, first let me run this and see what happens. So as you can see, here in this table, in first column, all the 2 rows are merged. Now, if you take a look at coding part, you can see that in first square bracket, I have written C because I want my merged column content to be center justified. In second curly bracket, I have written 2 because I want my 2 rows to be merged, and in third curly bracket, I have used star as I want my width as natural text width, and in final curly bracket I have written the contents of merged row. Now you are more than welcome to pause the video to note down the code and explore other possibilities. Next, let's say I want to put a horizontal line between this row X and Y and A and B. So let me try to put a horizontal line using usual hline command and see what happens. First, let me copy and paste the code of this table. Okay, now I'll write hline code here between X and Y and A and B. So if I run this, you can see that this horizontal line strikes out the contents of our merged row. So to resolve this issue, we need to use \cline command. Let me demonstrate an example of using \cline command in a table where we merge both row and column simultaneously. Here we will use \cline command. So \cline command is used for producing a horizontal line spanning one or several columns in a table. Let me give a demonstration by using the code. Okay, now let me run this. As you can see in output, our table is created where both rows and columns are merged simultaneously. Now if you take a look at coding section, here I have used cline command below this multi-column line, and in curly bracket I have written 1 to 2 because here I want to create a horizontal line spanning my first to second column below multi-row column. You may want to pause the video to note down the code and explore other possibilities. Now let us resolve the table 7 issue. As you can see here, since I have used hline command, it is striking out my multi-row text. So what I need here is a horizontal line spanning my second and third column below this XY row. So to resolve this, here I need to use \cline followed by a curly bracket in which I will write 2 to 3. So let me write the code now. So as you can see in this coding section, between X and Y and A and B, instead of \h line, I have used \cline in curly bracket 2 to 3, so that this horizontal line will span from second to third column. Now if I run this, you can see that our issue is resolved here, and there is a horizontal line spanning from this to this. So with this, let us stop tables part 2 section here. We have learned the basics of creating a fancy table, and with the help of the combination of these codes only, you can create your desired fancy tables easily. So do practice these basics thoroughly. Next, As we have already learned tables, I'll create a table consisting of few packages which I find extremely useful and I use them frequently. So as I have mentioned, there are hundreds, even thousands of packages are out there, most of which you will probably never use. So it is pointless to learn and remember all the packages. I'm just going to name a few packages which I personally find very useful and give brief definition about what they do. If you are interested to learn more about them, you can easily Google their documentation and read in details about their uses. Okay, let me write the table now. Okay, so these are the few packages which I personally find very useful, which are Fullpage, AMS Math, XYPic, Fancy SDR, ULEM, HyperF, XZ or PGF, BookTabs, Float, Geometry and AMS Fonts. You may pause the video and note down the names of all these packages and read their documentation to know more about them. So with this, let us conclude today's class. Don't forget to practice all the things you have learned here today in TechMaker, or maybe you can use Overleaf. In our next video, we'll learn about how to typeset various calculus notations in LaTeX. Thank you. Have a good day. Please like, comment, share and subscribe if you find this video useful.